What's a neural network? The math behind modern AI. If you have used modern AI tools recently, there is a good chance you have heard the phrase neural network. It appears in discussions about machine learning, image recognition, voice assistants, and systems like ChatGPT. The name sounds like something taken directly from neuroscience. And that is not entirely accidental. Neural networks were inspired loosely by how neurons interact in the human brain. But despite the name, they are not tiny digital brains sitting inside computers. They are mathematical models designed to recognize patterns in data. And those models have become one of the most powerful tools in modern artificial intelligence. So today we are going to walk through what a neural network actually is and how it manages to learn patterns from data. Chapter 1: The basic idea. At a high level, a neural network is a system that takes input data, processes it through several layers of calculations, and produces an output. The goal is to learn patterns that allow the system to make predictions. For example, a neural network might learn to recognize handwritten numbers, or identify objects in photos, or convert speech into text. The system improves its predictions by adjusting internal parameters based on examples. Over time, it becomes better at recognizing the patterns it was trained to detect. Chapter 2: The inspiration from biology. The term neural network comes from the idea of biological neurons in the brain. In the brain, neurons receive signals from other neurons, process those signals, and pass them along. Artificial neural networks borrow this concept in a simplified mathematical form. Instead of biological cells, the system uses computational units called nodes. These nodes receive input values, perform calculations, and send the result to the next layer of nodes. The structure forms a network of connections that process information step by step. The resemblance to real neurons is mostly conceptual rather than biological. But the name has remained. Chapter 3: Inputs, weights, and outputs. Each node in a neural network receives input values. These inputs might represent features of the data being analyzed. For example, in an image recognition system, inputs could represent pixel values from an image. Each input is multiplied by a number called a weight. Weights determine how strongly each input influences the result. The node then adds these weighted inputs together and passes the result through a function. The output of that function becomes input for the next layer in the network. By adjusting the weights, the system can gradually improve its predictions. Chapter 4: Layers of the network. Neural networks are typically organized into layers. The first layer is called the input layer. This layer receives the raw data. Next come one or more hidden layers where most of the calculations occur. Finally, there is an output layer that produces the final prediction. Each layer transforms the data slightly before passing it to the next layer. As the information moves through the network, more complex patterns can be detected. Simple features are identified early. More abstract patterns emerge in later layers. Chapter 5: Learning through training. A neural network learns through a process called training. During training, the system is shown many examples of data along with the correct answers. The network makes predictions and compares them to the actual outcomes. If the prediction is wrong, the system adjusts its weights slightly to reduce the error. This adjustment process is repeated thousands or millions of times. Gradually, the network becomes better at producing correct results. The process may sound repetitive, and in many ways it is. But repetition is exactly how the system improves its accuracy. Chapter 6: Deep neural networks. When a neural network contains many hidden layers, it is often referred to as a deep neural network. This approach is known as deep learning. The additional layers allow the network to detect more complex patterns. For example, in image recognition, early layers might detect edges or simple shapes. Later layers combine those features into larger patterns such as faces or objects. Deep networks have helped enable many recent advances in artificial intelligence, including speech recognition, language translation, and computer vision. Chapter 7 Example: Recognizing Images. To see how this works in practice, imagine training a neural network to recognize cats in photos. The network receives thousands of labeled images showing cats and non-cat images. At first the network makes mostly random guesses. But with each training step it adjusts its weights based on errors. Eventually it learns patterns such as shapes, textures, and arrangements that commonly appear in cat images. When a new photo is presented, the network analyzes those features and estimates whether the image likely contains a cat. Chapter 8 Why Neural Networks Are Powerful. Neural networks are powerful because they can learn patterns directly from data rather than relying on manually written rules. This makes them useful for tasks where the rules would be difficult to define explicitly. For example, writing a traditional program that recognizes every possible face would be extremely complicated. But a neural network can learn those patterns from large datasets of images. This ability to learn from examples has made neural networks central to modern machine learning systems. Chapter 9 Limitations and Challenges. Despite their impressive capabilities, neural networks are not perfect. They require large amounts of data to train effectively. Training can also require significant computing power. And sometimes the internal decision process can be difficult to interpret, because the network contains many layers of calculations that interact in complex ways. Researchers continue working on ways to make these systems more efficient and easier to understand. To wrap up, a neural network is a mathematical model designed to recognize patterns in data. It processes information through layers of interconnected nodes that perform calculations. Each connection has adjustable weights that change during training. By analyzing large sets of examples, the network gradually learns patterns that allow it to make predictions. Deep neural networks with many layers can detect complex patterns and power many modern AI applications. Neural networks may sound complicated, but the core idea is surprisingly simple. They learn patterns by adjusting connections between many small computational units. Given enough data and computing power, this approach allows machines to perform tasks that once required human judgment. And that is why neural networks have become one of the key technologies behind modern artificial intelligence. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. Comment below what other topics you would like us to cover. See you in the next one.